It's a sound we all know and dread. That high-pitched whine that signals the end of a perfect summer evening. Mosquitoes, the uninvited guests at every outdoor gathering, the bane of campers and gardeners alike. But what if we could change that? What if we could rid the world of every last mosquito? It's not just about comfort. Mosquitoes are more than a nuisance. They're deadly. These tiny insects are responsible for more human deaths than any other animal on the planet. Malaria, dengue fever, Zika virus, West Nile virus, the list goes on. Every year, mosquito-borne diseases affect millions and kill hundreds of thousands. In many parts of the world, the constant threat of these diseases shapes daily life, healthcare systems, and even economies. So, the question isn't just hypothetical. It's one that scientists, health organizations, and governments have been seriously considering. What if we could eliminate all mosquitoes? What would happen to our world? Let's imagine we've done it. Through some combination of advanced gene editing, targeted pesticides, and global cooperation, we've managed to wipe out every mosquito on Earth. What happens next? The immediate effects would be dramatic. Mosquitoes are a fundamental part of many ecosystems. They serve as pollinators, decomposers, and a crucial food source for numerous species. Their sudden absence would send shockwaves through food webs around the globe. Let's break this down. First, let's look at who eats mosquitoes. Birds, bats, fish, frogs, lizards, and even some plants rely heavily on mosquitoes for food. In the Arctic tundra, migratory birds feast on dense swarms of mosquitoes to fuel their long journeys. Without this food source, many bird populations could crash. But it's not just about who eats mosquitoes. Mosquito larvae play a crucial role in aquatic ecosystems. They feed on organic matter in the water, helping to recycle nutrients. They also serve as food for fish and other aquatic life. Without mosquito larvae, some water bodies could become choked with algae and detritus. And let's not forget pollination. While mosquitoes aren't as famous for pollination as bees, they do play a role. In the Arctic, mosquitoes are significant pollinators for some plant species. Their loss could lead to declines in plant diversity in these sensitive ecosystems. The ripple effects could be enormous. Species that depend on mosquitoes might decline or even go extinct. This could then affect their predators, and so on up the food chain. We could see cascading effects that reshape entire ecosystems. From a human health perspective, the elimination of mosquitoes would be revolutionary. Mosquito-borne diseases kill over 700,000 people each year. Malaria alone affects more than 200 million people annually. The eradication of these diseases would save countless lives and fundamentally change healthcare in many parts of the world. Resources currently devoted to mosquito control and disease treatment could be redirected to other health initiatives or social programs. But here's where it gets complicated. Mosquitoes have been around for over 100 million years. They've co-evolved with countless species, including the pathogens they carry. If we remove mosquitoes, could these pathogens find new ways to spread? Virologists, it's a serious concern. Nature abhors a vacuum. If we eliminate mosquitoes, other insects could potentially step in as disease vectors. We could also see existing pathogens mutate to find new hosts. We might solve one problem only to create others we can't predict. And then there's the question of how we'd actually achieve global mosquito extinction. The technology required would be unprecedented. Currently, we use a combination of insecticides, habitat modification, and biological control methods to manage mosquito populations. But to completely eradicate them would require something far more powerful and wide-reaching: genetic engineering. One promising approach is gene drive technology. We could potentially modify mosquitoes to pass on genes that prevent them from reproducing or from carrying diseases. But releasing genetically modified organisms on a global scale raises serious ethical and safety concerns. The ability to intentionally drive a species to extinction is a power that humanity has never wielded before. It raises profound ethical questions. Do we have the right to eliminate an entire species for our benefit? What about the potential for misuse? The mosquito question forces us to grapple with some fundamental ethical dilemmas. On one hand, we have the potential to save millions of human lives. On the other, we risk causing ecological damage on a global scale. It's a classic case of weighing short-term human benefit against long-term ecological stability. And let's not forget, there are over 3,500 species of mosquitoes, but only a few hundred bite humans, and only about 40 species are significant disease vectors. Would we target only those species? Could we do so without affecting the others? The complexity doesn't end there. Mosquitoes, annoying as they are, have shaped human history and evolution. They've influenced where and how we live, impacted the outcomes of wars, and even affected the development of human immune systems. Mosquitoes have been a selective pressure on human populations for millennia. They've influenced human genetics, particularly in regions where malaria is prevalent. Removing this pressure could have unforeseen consequences for human evolution. As we've seen, mosquitoes play a role in virtually every ecosystem they inhabit. They're pollinators, decomposers, and a food source. Their larvae help filter water systems. Removing them would be like pulling a thread from an intricate tapestry. We can't be sure the whole thing won't unravel. So where does this leave us? As we stand on the brink of powerful gene editing technologies, the mosquito question is more than just a thought experiment. It's a challenge that forces us to confront the complexities of our relationship with nature. The debate over mosquito eradication brings together ecologists, public health experts, ethicists, economists, and more. It's a testament to the interconnectedness of our world and the far-reaching consequences of our actions. We need to consider the long-term ecological consequences. Mosquitoes have been part of Earth's ecosystems for millions of years. Their sudden removal could have impacts we can't fully predict. The potential to save millions of lives can't be ignored. But we need to be certain we won't be creating bigger problems down the line. This is a decision that would affect every person on Earth, as well as countless other species. It's not one to be taken lightly. We're developing the tools to make this possible, but the question is, should we use them? And if so, how can we do it responsibly? As we contemplate this tiny insect, we're forced to grapple with big questions. Questions about our place in nature, our responsibilities as a species, and the unintended consequences of our actions. What do you think? Should we swat away mosquitoes for good, or learn to live with our tiny, whining neighbors? The answer isn't simple, but the conversation is crucial. Because remember, the next time you hear that familiar buzz, you're not just listening to an annoying insect. You're hearing the sound of complex ecosystems, evolutionary history, and the intricate balance of nature. A balance that we, for better or worse, have the power to alter. The mosquito question challenges us to think beyond our immediate discomfort and consider our role as stewards of the planet. It reminds us that in nature, everything is connected and no action is without consequence. So what's your take? Join the conversation in the comments below. And the next time you reach for that bug spray, take a moment to consider the buzz beyond the bite.